Excellent. Hi, and welcome to this live edition. And basically, what I want to do is go through questions. You're more than welcome to leave comments about things you want me to go through or anything like that. And we've already got our first message. Okay, you should never ever rely on predicted papers as accurate things of things that are definitely going to come up. It's all just based on statistics and probabilities. The best predicted papers are always going to be paper 2 and paper 3 because we know what's come up on paper 1 or we know what's come up in the previous papers. So always make sure you check them out. But you see the predicted papers as a revision tool and nothing more. Right. So what we're going to do is go from grade 1 all the way up to grade 9, and we're just going to repeat that until we are happy. And along the way, if you want to drop a message, then feel free to. I think the thing is, YouTube is not very good at showing what people are saying on comments. So I've got my phone here as well, just so I can pick them up. They don't always show up, which is really annoying. But I'm going to get going because I've waffled on too much. So this first one is an OCR paper 2. Now you might be thinking, well, hang on, OCR paper 2, that's not paper 1. OCR do this weird thing where they have the non-calculator as paper 2. So this is kind of paper 1 for everyone else, right? It says a fair spinner has 6 sides. They're labelled 1, 1, 2, 4, 4, 5. And the diagram shows the probability scale. All very interesting. And it is asking us to which arrow shows the probability of scoring a 2. Okay, so how many 2s are there? There are 1, 2. There is 1, 2, and there's 6 altogether. And so let's have a look. So this will be halfway, right? This will be a half. And this will be, what, a 1/6. And then this will be 2/6. And 3/6, 4/6, 5/6. Okay. So which arrow shows the probability of scoring 2? There's 1, 2, and there's 6 altogether, so that's going to be B. Scoring a number less than 6. Well, they're all less than 6, so it is going to be E, because they are all less than 6. And finally, scoring a 1 or a 4. Let's have a look at 1 or a 4. So 1, 2, 3, 4. 4 of them are a 1 or a 4. And so 4/6 or 2/3 is going to be D. So our answer is going to be D. Fantastic. Grade 1 sussed. Let's move it on. And let's see what we get for grade 2. Oh my goodness. Another probability question. Oh, let's do the top one. Why not? So question 10. Let's just make sure everything's set up. This isn't quite as smooth. We're asked to find whether these are equations, expressions, formula, inequality, or term. Oh, that's interesting. You don't normally get that last one. This is what I need to sort that out on the machine. Reprogram it. Okay. Anytime you've got something without an equal sign, it can't be an equation or a formula. If it doesn't have like a less than or greater than sign, it can't be an inequality. It can't be a term because there's actually 2 terms here. There's a term here and a term here, so it can't be an inequality. So it has to be an expression. So this will be expression. Next one, it's pi r squared equals 30. So this is quite a weird one because you'd think that this is a formula because that looks like a formula, but because it actually is equal to something, it's not a formula because you can work it out. Anything you can solve is going to be an equation. Sweet. Right, let's move on to grade 3. And trying to like get my... Okay, there we go. Cool. Alright, so we are halfway through one there, so we're going to go down. Circle the equation of the line. Oh, wow. So it's quite a hard grade 3 one, although it's question 17, so it's maybe more grade 4, who knows. And there's no such thing as grade. There's no such thing as this question is X grade. This is all just sort of roughly. So we're going through the origin. And so there's no y-intercept. So anything with a y-intercept can go. It just takes one off. In fact, y equals 6 will be a horizontal line. So that's not going to be the right one. So we've got two gradients here. We've got a gradient of 3 and a gradient of a third. If you put in the x value, it should equal the y value, right? So x is 2, so y equals 3 times 2. Y would equal 6. So that's the one there. If you put it into the other one, then it would not equal 6, because a third of 2 is not 6. So it's the third one along. Right, grade 3 done. Let's move on to our grade 4 question. Okay, which one do we fancy? 23 or 24? Let's go for 24. Okay. And let's just set this up. Just check everything's all hunky-dory, which it is. Good. Okay. Sean pays £10 for 24 chocolate bars. He sells all 24 bars for 50p each. Work out Sean's percentage profit. So sells all 24 for 50p. So it's 24 times sort of £0.50, right? So half of 24 is going to be £12, right? So he sold them for £12. He bought them for £10, and percentage profit is the change, which is going to be £10 to £12, which is 2, over the original, which is 10. 2 over 10 is 0.2, and as a percentage, that would be 20%. So his percentage profit is 20%. Cool. Right, let's move on. And we've got blank page here, and this is what happens with the automator for grade 5, is you've sort of got to go back a little bit. And what do we fancy? I fancy doing the top one. Okay, because I like rearranging. So y equals 3w minus 10, and we can put our lines in, make it a bit nicer. And so when we are making w the subject to the formula, it means that we want to end with w equals. And so the first thing we want to get rid of is that minus 10 there. So we're going to add 10 both sides. Nice and simple. Y plus 10 equals 3w. Next we need to get rid of this times 3, and to do that we divide by 3. And so we've got y plus 10 over 3. And make sure it's all over 3. So our answer will be w equals y plus 10 and all of that over 3. And that's just... yes, it's gone a bit weird. I don't know why. Bit of the behind the scenes is not going as planned, but so there'll be. Okay, grade 6. This is where things get a bit interesting. Okay, so where are we up to? Right. Imran joins two tiles together. Okay, so we're looking at exterior angles. The worst thing to do here is try and think of interior angles, because it's going to take you ages. Best thing to do is think of exterior angles. Why? Because we've got a line here coming off both of these, and it's a pentagon and a hexagon. Okay, so we're going to find out this, which I'm going to call x, and we've got to find out this, which I'm going to call y. So x is the exterior angle of the hexagon. Yeah, it's that way around. So to do that, to find out what it is, we just get 360 and we divide it by 6, which is nice because it's just 60. So we know x is going to be 60 degrees. Y is going to be the same. It's going to be 360, but this time it's going to divide by 5. And if we divided it by 10, that would be 36. Divided by 5, double that, 72. Cool. And then finally, what we've got to do is just add the two together, right? So A is going to be 60 plus 72, which thankfully is 132, because that's what it asks us to find in the question. Phew, we've got it right. Imran thinks of another tile in the shape of a regular polygon that will fit exactly into angle A. Is Imran correct? This is $1 million question, right? Is Imran correct? Sorry, I'm just doing things behind the scenes here. So we've done exterior angles, and we know that to find an exterior angle, they are going to add up to, you do 360 divided by the amount of sides. But this one here would be A would be an interior angle of this. So what we could do is work out what the exterior angle would be. And this is not the only way of doing this. This is what I would do. And interior angle, which is the 132, if you take it away from 180, you get the exterior angle, right? So we just do 180, take away 132, which is 48. And then all we need to do then is 360 divided by 48. Now, you probably could start dividing that by 2. Let's say this is where I get messy here. So it's 24, and then that divided by 2 again, and then divide by 2 again. It's probably a quicker way of doing this. Divide by 3. 15 over 2, and then that would be 7.5. So the answer would be no, and something like the number of sides cannot be 7.5 or something like that. Sweet. Right. Question in the chat is this foundation? What I'm doing is grade 1 to 9. So grade 1 to 5 are all foundation questions, and then grade 6 to 9 are all higher. So this one is the first of the higher ones I'm doing. Don't worry, I'm going to loop back to grade 1 after I've done some grade 7, 8 and 9 questions, which I'm not necessarily looking forward to doing live, but c'est la vie. So we're asked to complete this table. We've got like a reciprocal graph going on. 6 divided by -3 is -2. 6 divided by -2 would be -3. Oh, is that it? We just got to do 1. Okay. Draw the graph. Okay, so we've got -6, -1. Okay, so this will show my graph making skills here. -3, -2. Is that right? -2, -3. -1, -6. 1, 6. 2, 3. 3, 2. 6, 1. Is that all right? Now, reciprocal graphs. I'm just going to draw one quickly over here, and then we'll try and do it. They either look like this, or, if you're lucky, like that. I say if you're lucky, it doesn't really matter. So it's going to be one of the two. We've got the blue one, and so ours, and I'm rubbish at doing this on this tablet, but make sure. Oh, that was awful. No, I'm not going to let that go and go. I'm going to go the other way. Always turn the page so that it makes it easier for you. I can't do that with this tablet, but if I've got a piece of paper in front of me, I would turn it so that I've got a nice view of where I'm going. And what I'm looking for when I mark this is, have you missed any? Like there, I've missed it slightly. I might get away with that. But if you've got like a cross here and you completely miss it, I'd probably knock a mark off for that. It needs to be one smooth line, no feathering, so none of this rubbish. You will instantly lose marks for that. It has to be one line, but I'm not looking for perfection. The one you see on screen now would give you full marks. So this is higher. So it's grade 7. If you look on the left hand side, it says what grade it is. And if it's grade 6 to 9, it is higher. But I'm going to loop back around. So this video, live stream, will go through higher and foundation. I'll just go from grade 1 to 9. Right. Is that it? Yeah, that is it. Sweet. That's not such a bad one. Okay. Grade 8. Oh my goodness. What is going on with this question? Okay. Right. What have we got? Okay, just one sec. Get myself set up. Okie dokie. So show that the value of 6 sine 30 plus 2 cos 30 times 4 tan 30 is an integer. Wowee. Okay. So in response to the chat, I'm going to go through grade 1 to 9, and the questions will be randomly from Edexcel, AQA, OCR and Eduqas. So they are all questions that can come up. If there's a question that I know won't come up on some of the exams, I'll just skip it. So Eduqas, for instance, do questionnaires, which no one else does, so I'm just going to skip that. So we're focusing on ones that will be appropriate for AQA Foundation when I've done the grade 8 and grade 9 question. So the first thing to realise is that sine 30 is a half. Well, so we've got cos 30 here. So cos 30 is root 3 over 2. And you might be thinking, where am I getting these from? You just need to know these. Tan 30 is 1 over root 3. You might know that as, was it root 3 over 3? Just rationalise the denominator. So we've got 6 times a half plus 2 times root 3 over 2 times 4 times 1 over root 3. Okay, so that will be 3 plus 2 times 4 is 8, and root 3 times 1 is root 3. I'm just timesing the fractions together. 2 times root 3 is 2 root 3. Got root 3 top and bottom, so that would just be a half. And we've got 3 plus 8 times a half, which is 4. 3 plus 4 is hopefully 7, if I've done it right. So our answer will be 7. It says show that it's an integer. Well, 7 is definitely an integer. It just means a whole number. Sweet. Right, grade 9, and then we'll loop back to grade 1. And this is, again, like the grade 5 before. I've got to sort of go back a bit. Okay. Right, let's just set up. And check we've got everything. It's really weird. Okay. Find the coordinates of the turning point of the curve with the equation there. Oh my goodness. That's horrible. You must show you're working out. Okay. I can't be bothered to do that one. I'm going to skip because a lot of people are saying foundation. So I'm going to loop back again. That's a horrible question. Shall I do it though? It looks quite tempting to do. What do you think? Is there anyone who wants me to do this, or do you want me to go back to grade 1 and do some foundation ones? I'm going to take your first answer because you would do complete the square, which is horrible to do with negatives. Right, I'm going to loop back. We're going to go back to grade 1. So, grade 1. Okay, so here is a rectangle. Work out the area of the rectangle. Have we gone like ridiculous? Gone from sublime to ridiculous here. Okay, this is quite a nice one, isn't it? Area of a rectangle is what, 4 times 6, right? And just 24. Sweet. Okay, that's a very, very simple way to start. What is that? OCR 2024 November. That's a lovely question, eh? Right, grade 2. These are all foundation. Oh my goodness. That's a lot going on there. And that's just part A. I'm gonna re-roll. Re-roll grade 2. Okay, here we go. Let's just set up behind the scenes. Okay. So we are asked to work out an estimate for the value of 92 times 1.63 and show your working. Whenever you're asked to estimate, you have to round to one significant figure for everything. So 92 to one significant figure will be 90. And 1.63 to one significant figure will just be 2. So it would be 180. So our answer would be 180. Simples, eh? So just remember one significant figure. Right. The next one is a given that question. And are we going to have... No, we don't need to rearrange this. Sweet. So we've got 2.96 times 3.2 equals 9.472. And we've got hang on, let's leave a little bit of space. 29.6 times 32. So we know the answers will have the digits 9472, and we've got to work out which digits, right? So what have we done to here and what have we done to here? So what we've done to the 2.96 is we've times it by 10. What we've done to the 3.2 to get to 32 is, again, we've times it by 10. So our answer we're going to times by 100 because we've times it by 10 and times it by 10 again. So that would be 100, right? So to times by 100, times by 10 would be 94.72, times by 100 will be 947.2. So it would be 947.2. That's quite a nice one. I quite like that one. Right, let's move on to grade 3. These are all foundation ones. Oh, this is a good question. I like algebra and shape. Whenever the two come together, happy days. The diagram shows a rectangle. Got a second rectangle so far. And we've been given what AB is and BC is. And we've been given the perimeter. And we're asked to find the value of x. Okay. So whenever you have algebra and shape, there are two ways of saying the same thing, right? And I'm going to put my lines in now. There are two ways of saying the perimeter. We know that the perimeter is 40, so that's one of the ways that we can write it, 40, right? The other way is by adding up each of the sides, right? And a rectangle has the same lengths on both sides. So if we start here and work our way around, that would be 12 plus 2x plus 3 plus 12 plus 2x plus 3. Now if we collect the like terms, we've got 2x plus 2x, that would be 4x. Got 12 plus 12 is 24, plus 6 is 30, hopefully. This is where I make silly mistakes because I'm rushing. We're going to take away 30 both sides. That would be the first thing we do. So we're left with 4x on the left hand side, take away 30 from the 40, we're left with 10. This is not looking good. I never like it when I'm left with a decimal. So we're going to divide by 4 both sides to get rid of that 4 before the x. And 10 divided by 4, halve it, it's 5, half it again, it's 2.5. Now I'm never happy when I have a decimal. So I always double check it, but looking at it and double checking it in my head, it is 2.5. So just when you've got some time left in the exam, if you're ever left with a decimal, it doesn't mean it's wrong, which this one is correct. It just sort of reminds me to double check it a little bit and check that it's all hunky-dory. Right. Next one. Got grade 4. Okay, so large circle and small circle are shown. The radius of the large circle is 12 centimeters. Okay. So we've got the radius there of 12 centimeters. The radius of the large circle is, if it's 12, and it's a 4 to 1. Okay, so it's 4 to 1. So if that's 12, we're going to divide it by 4, and that would be 3. Okay, so that would be 3 centimeters, right? Work out the shaded area. So area of circle is pi r squared. Area of the big one is going to be therefore 144 pi, because r squared, 12 squared is 144. Take away, it's going to be 3 squared, which is 9, so it would be 9 pi. And that would be 104. So imagine that this is x, right? So 144x, take away 9x, would be 135 x, but we're doing it in terms of pi, obviously, so it's going to be in pi. And that is our final answer, I'm hoping. Yeah, perfect. And that's 4 marks. Cool, let's move on to grade 5. If I press the right button. Okie dokie. Oh, another make the subject. I like making things the subject. When you want to make something the subject, you do q equals. That is the objective. So we're going to start with p equals 6q plus 7. And we're going to draw our lines in. So first thing we want to get rid of is that 7. So we're going to take away 7 both sides. And we have p minus 7 equals 6q. Next thing we need to do is get rid of this times 6. So we're going to divide 6 both sides. So p minus 7, to divide 6, all of that, you've got to put it over 6. And then we're just left with q. Sweet. So we've just got q equals p minus 7 over 6. Next we're going to simplify some indices. And the rule is that whenever you've got, in fact I should write the answer here. Let's just quickly write the answer. There we go. Whenever you've got indices inside and outside of a bracket, you just times them together. So it'd be m to the power of minus 2 times minus 3. Whenever you've got two negatives multiplied together, you get a positive. 2 times 3 is 6. Sweet. Right, I'm going to stick with the foundation unless someone says otherwise. Is Eduqas an upgrade to functional skills? No, Eduqas is just an exam board. It's like Edexcel, AQA or OCR. So Eduqas paper. The only difference is they only do 2 papers, but those 2 papers are very, very long. They're not an hour and a half. They're like 2 hours and a quarter or something. Can't really remember. Okay, I'm going to go back to grade 1. Let me know if you want me to cover any higher stuff, but I'm going to just keep going grade 1 to 5 because that is what I've been asked for so far. Right, where are we going to start? Work out, oh god, I hate these division ones. Work out 280 divided by 7. So I'm going to do what, bus stop method. 7's into 280. 7's into 28 go 4, hopefully. 7's into 0 goes 0, so it'd be 40. It's a nice way to start, isn't it? Nice grade 1 question. Right, let's go to grade 2. And, oh wow, this is quite a lengthy one. Which letter is the mode? Mode means most common. C comes up once, A comes up twice, and B comes up thrice, or 3 times. So the B is the mode. One of the cards chosen random. Mark with an arrow, the probability has an A on it. Well, there are 2 A's, so it will be there. Let's just check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think that's right. We'll write down the probability that the card chosen has a letter C on it. So that would be 1 over 6. Because there are 6 cards altogether. 1 has a C. Write down the ratio of the number of cards with the letter A to B. So there are 2 A's and 3 B's. That's quite nice. So we are covering Edexcel, AQA, OCR and Eduqas. But I'm not going to cover anything that's not on all 4 exam boards. So we're doing questions that are on all 4 exam boards. So if you're doing Edexcel, all the questions I'm covering could come up on the paper for the Edexcel on Thursday. Right, let's move on to grade 3. Okay, I'm going to do the second one because I've answered that one earlier, or similar one earlier. So 36 as a product of prime factors. Everyone has a different way of doing this. It doesn't really matter which way you do, but you're splitting the number up by 2 numbers that multiply together to make it. Always pick 2 if you can. And whenever you find a prime, you circle it, because then you're finished. What is it? 2 times 18 is 36. 18 is not a prime, so we keep going. 2 times 9. Now 9 you think may be a prime, but actually 3 times 3 is 9, and 3 are primes. The word product means that you have to put a times between them, so it'd be 2 times 2 times 3 times 3. And if you actually did 2 times 2 times 3 times 3, you would get 36. Sweet. Grade 4. Oh, we did this one earlier. So, yeah, done this one. Let's do a re-roll. So we go back to grade 4. Let's re-roll it. Okay, we haven't had this one. Find the percentage of pupils who took more than 30 minutes. Oh my goodness, right. So this is 90 here. And what is it, 150 there. And 60 there. And so as a percentage, so does it say how many in total there were? No, we have to actually work that out ourselves. That's really annoying. So 150 plus 90 is 240, plus 60 would be 300. So 300 altogether, and there's 90 who are more than 30, so it'd be 90 over 300 times 100, right? To make a percentage. This must be easier ways of doing this. I think I'm making this really difficult. You might be thinking this is paper 2 on the OCR. OCR do their non-calculator on paper 2. So to make sure that this is all relevant for everyone's exam on Thursday who are doing paper 1 for Edexcel, AQA and Eduqas, I'm just going to go through all the non-calculator papers. So actually I'll tell you what, it'd be easier. Just times the 100, so that would cancel that, and it'd be 90 divided by 3, which is 20, right? So it'd be 20%. Actually, it's already got a percent sign there. Whoops. Okie dokie. On Tuesday, the number of pupils taking 10 to 30 minutes to travel to school was 25% less than on Monday. Find the number of pupils taking 10 to 30 minutes to travel to school on Monday. So these all were on Tuesday, right? So we've got like a brand new situation here. On Tuesday the number of pupils was 25% less than Monday. Oh my god. Right, 10 to 30 was 150. So we can get rid of all that, and it's 150 was 25% less than Monday. Right. So we've got Monday, and we're going to take away 25%, take away a quarter, and we get 150. So what number do you take away a quarter and you get to 150? I'm trying to think. I'm very happy to do this with a calculator. I'm trying to figure out a way of explaining this without a calculator. So we've got 100% and we've got 75%, right? So 75% of it is 150. So 25% of it would be a third of that, right? Which would be 50. So therefore 100% of that would be 4 times that, which would be 200. That's so much easier with a calculator to explain it. Anyway, right, now we're going to move on to grade 5. So let's see what the dice roll gives us. Oh, tree diagrams, sweet, and they're decimals as well, fantastic. And we've got different probabilities on Tuesday, and they seem to be dependent on what you got on Monday, so this is good. Notice that these two have to add up to 1, so this and then this one has to add up to 1, so it'd be 0.7. This one and this one have to add up to 1, so it'd be 0.9. So complete the tree diagram, done. All the ones along the way have to add up to 1. Calculate the probability that Kathy cycles to work on both Monday and Tuesday. Right, so you're going to follow the tree across, and we're going to cycle on Monday, and we're going to cycle on Tuesday. And everything, all the probabilities we collect along the way, we multiply them together. So we're going to do 0.6 times 0.3. Let me just set this up, that's it. Okay, so to do that we can do 6 times 3, which will equal 18, but this one we're going to divide by 10, and we're going to divide by 10 for this one, right? So our answer will be 100th of that, so we're going to divide 18 by 100, 0.18. So our answer is 0.18. Okay, calculate the probability that Kathy does not cycle to work on either day. Don't quite understand how this is different, but maybe it's not. So, does not cycle down this one, does not cycle down this one. And we're going to cross that 0.4 and 0.1. And so, we're going to do 0.4 times 0.1. Now, when you times by 0.1, that's just a tenth. So find a tenth of 0.4. We get 0.04 would be our answer. Do you think the grade boundaries will be lower this year or higher? I mean, I'd never worry about the grade boundaries, because the grade boundaries will be higher or lower depending on how well people did on the paper and how hard they think the paper is or how easy it is. Don't think about grade boundaries, just think about like the questions that will come up and making sure you're maximizing your marks by getting at least 1 mark in the hardest, most horrible questions. Try and get the first few marks at least. Right, let's go back to grade 1. I've said this before, but if you've just joined, I'm only going to do the foundation because it's what people have been asking for. But if you want me to do the higher, just let me know, and I'll do some higher ones as well. Oh, this is a nice one. Write 4 over 5 as a percentage. So first thing we're going to do is get the bottom to be 100, right? So I'm going to times them both by 2, and then times them both by 10. And then we're left with 100 at the bottom. Percent just means per 100, right? Cent is, I don't know, Latin for 100, right? So it's 80 per 100 or 80%. Sweet. How nice is that? What a nice start. Grade 2. Let me go down here. Oh my goodness. What is going on with this? I'm just going to go on to the next page. This looks even worse. Which is this? Eduqas. Oh, okay. They rabbit on a bit with Eduqas. Okay, so this is the one we've come up with, so I've got to stick with this, I suppose. A health food shop. So this is the one that most students just sort of zone out and sort of leave blank, but we can get some marks here. So, right, we're asked to find which bottle is better value for money. So we've got 16 tablets at 220 pence, and we've got 24 tablets at 350 pence. right, how are we going to get those the same? Because, like, if one's got 24, so one's £3.50, you go, oh, well, that's not better value, but it's got more tablets, right? Now, you could find out the price per tablet or the amount of tablets per penny, but notice 16 and 24 are both in the 8 times table, right? So we can convert them into, we can halve this one, so 8 would be 110 pence, and we can divide this one by 3. So we're halving this, so divide by 2, and we're dividing this one by 3, and divide that by 3. Can I do that divided by 3? Probably not. Let's do a bus stop method to make absolutely sure. So 3's, I don't know why I've crossed that out, that's really stupid. 3's into 5 go 1, carry the 2. Oh, this is going horrible, isn't it? Because that would be, what, 6? Is this not going well? Does this not, like, work nicely? I feel this, oh, this is paper 1. How has a paper 1 come up when I've specifically said not paper 1? So this is a calculator 1, so we're going to re-roll. That's really annoying. See, I'm annoyed with my own program. So what were we up to? Were we up to grade 3? I think we're up to grade 3. Is this paper 1 again? Right, let's have a look and see. Do you know what? I'm just gonna keep re-rolling. Oh no, it's paper 1 on Eduqas is okay. I think I'm losing it. Okay, we've got recipes 1. It's OCR I was thinking of, was paper 2. That's a horrible one. Right, anyway, how many eggs does he need to make 60 cupcakes? So this time we've got 20 cupcakes here, so we're going to times everything by 3 we're going to times the eggs by 3 to make 60. So it'd be 4 times 3, which will be 12. And let me just set up something, hang on. Alright, cool. Okay, how much butter to make 5 cupcakes? 20 divided by 4 is 5, so we're going to divide the butter by 4. When you divide something by 4, you halve it and then halve it again, so it'd be 35. Because half of 140 is 70, half of that's 35. Sweet, we're doing well so far. Rashid has 210 grams of cocoa powder and plenty of other ingredients. He says he can make at least 75 cupcakes. A little bit of a tip, if it says, is he correct, almost always they're not. Sometimes they are, but almost always they're not. So 210 grams of cocoa powder, so 60. So 60 is needed for 20. So 60 grams makes 20 cupcakes. So I don't know, I'm trying to think about what to do for this. We could do 1 and divide it by 20. There's so many different ways you can answer this question. So it'll be 3 grams per cupcake. And so 75 cupcakes. We'll need, divide that by 3. Don't need to do bus stop, but I will. 25. Why have I done bus stop for that? That was too easy. So, oh no, it'd be 250, wouldn't it? I'm being tense. That makes literally no sense. How have I divided by 20? And then I times by 75. So it should be that times 75. Wow. Okay, so 3 times 75. 21, 22, right? So 220. There we go. Got there eventually. I don't know where I was going with that. 225. Wow. So is he correct? No is the answer. So let's just scroll down. So no, he needs 225 grams. Right, let's move on. Okay. We've got a nice standard form. Oh my goodness. Wowee. Now, if we're working this out in standard form, I could write this in standard form, right? So decimal point goes there and count the jumps. So 1, 2, 3. And decimal point goes 1, 2, 3, 4. So it'd be times 7 times 10 to the power of 4. And then 2 times 7 is 14. 10 to the power of 3 times 10 to the power of 4. Add the powers together, it'd be 7. But this is not standard form, annoyingly, because it needs to be 1.4. And sometimes you can get easily confused with which way we're going with this. So sometimes it might be easier just to convert this back to a normal number, right? So 7 jumps, 1, 2, 3, 4, 5, 6, 7. And to make it 1.4, we're going to do 1, 2, 3, 4, 5, 6, 7, 8. 8 jumps. So it'd be times 10 to the power of 8. So it'd be 1.4 times 10 to the power of 8. Heavily losing my voice at the moment. This is not good. Okay, next, work out that. So what you can do with these is just split them up into 2, right? Do that bit and do that bit separately, right? So 1.8 divided by 3. Well, what's 18 divided by 3? It's going to be 6. So what's 1.8 divided by 3? 0.6, right? Times, and then we are doing 10 to the power of 2, take away, because with indices when you divide you take away, minus 1, right? So it'd be 10, 2 take away minus 1, 2 minuses make a plus, so that would be 3. But again, we need to convert this to standard form. So we're going to do 1, 2, 3. And then it would be 1, 2. So it would be 6. I'll put this in the bottom bit. 6 times 10 to the power of 2. Oh no, it wants it as an ordinary number. So we just write 600. There we go. This is why you should check. Always check your question before you commit to an answer. Okay, let's go to grade 5. And we've gone too far. What do we fancy? Let's do some factorizing quadratics, because I've already done standard form. So whenever you have a quadratic, that's an x squared term, an x term, and a number term, you're going to put a set of brackets down. On foundation, all you need to do is put an x here and an x here. You need to find 2 numbers that add together to make the number before the x, and times together to make the number at the end. So they need to add together to make 2, and times together to make minus 24. Now to make a minus, when you multiply numbers together, one has to be a plus and one has to be a minus. Notice that when they add together, they're going to be a plus. So this number here is going to be the bigger of the 2, the larger of the 2 numbers. And we need 2 numbers that are factors of 24 that have a difference of 2. So it's not going to be like 24 and 1, because there's a huge difference between them. 6 and 4 is where I'm going to go. So if I put a 6 here and a 4 here, 6 times minus 4 is minus 24, sweet. And 6 plus minus 4 is 2, so that works nicely. So it's going to be x plus 6, x minus 4, sweet. Right, I'm going to go back to grade 1, as I keep saying, if you have been here for a while. If you are doing higher, let me know, and I will do some higher grade stuff. But I think most people have said that they're doing foundation, so I'm going to stick to foundation for now. Oh my goodness. Wow. Wordy. Is this OCR, yeah. So question 3, a 100-gram packet of tea costs £4.16, 25-gram packet of the same tea costs £1.05, which is better value for money? So first thing you can do is just make them both the same thing, and I always make it in pence. I'm going to make them both out of, I'm going to convert them both to 100, right? The top one's already 100, so I'm going to times this one by 4. And we get 100 grams is that times 4, so it'd be 420 pence. Which is bigger, 416 or 420? Obviously the 416 one is better, so the 100-gram packet is the better value, and you can show it through you're working out. I don't know, if you've got some time, you can make it a bit more clear, but I think if I was an examiner, that would be enough for me. Oh wow, okay, so we've got a nice distance time graph to try and get ourselves around. What was Oliver's average speed between 1 o'clock and 3 o'clock? So here and here. So average speed is the total distance over the total time. The distance, I'm imagining, is 20 miles. Yeah, 20 miles. And the time is 2 hours. So that's going to be 10 miles per hour. Sweet. Give an explanation for the shape of the graph between 5 and 6 o'clock. So that is here and here. So what's happening? Well, time is ticking. Well, time always ticks. That's what time does. But the thing that's not moving is the distance. Distance is staying at 40. And so, like, he's stationary. Or he's stopped, or whatever, so he's not moving. Between which two times was Oliver cycling at his greatest speed? So greatest speed is highest gradient, and what I can do, this is the clever thing about this machine, right, is I can actually show you that this and this have pretty much the same gradient. Okay, these ones are like horizontal, but this one here, this one round here, has the steepest gradient, right? You're gonna sort of push this right the way up to get it level with that. Okay, so it is, and you can do this with your ruler. It is between, in fact, let's just mark it on the diagram, and I'll do it with pink. So it's between this one and this one, so it's 330 and 4. Right. So 330 and 4. Oliver started the final part of his cycle ride at 6. He cycled 20 miles at a speed of 8 miles per hour. Draw the part. Okay, so he's currently... what's this? Yeah, some of these journey rooms. Oliver went for... are we going up or down? That's always the question. I think we're still going up, aren't we? 'Cause the distance, it's distance, not displacement. So 20 miles, an average speed of 8 miles per hour. So 20 miles means we're going to go up to here. So we'll make it to that line. And if it's 8 miles per hour, did it say? Keep checking it. So it's 8 miles per hour. Right, so how many 8s are there in 20? What? Oh my goodness, no, I was right. So there are 2 whole ones and 1 half one. So it'd be 2.5. So it's going to take 2.5 hours. So it's going to end here, and it's at a constant speed, so we just need to connect these together like that. So it'd be at 8:30 it would hit that 60. That was horrible. I don't know why it took me so long with that one. Grade 2, wow. Grade 3, let's hope this is a nice one. And let's go for the top one. Find the expression in terms of n for the nth term. Okay, so a few things you need to know for the nth term. First of all, what it's going up in, and it would help if I've got the right function. Let's just delete that. Right, what is it going up in? And it's arithmetic, or arithmetic. So it's going to go up in the same amount each time. So that's going to be +8. That's going to be +8. That's going to be +8. So if it's going up in 8, then we straight away can say it's 8n. So it's similar to the 8 times table, but it doesn't start at 8. The 8 times table has to start at 8. To work out what the bit at the end is going to be, is we go back and find the 0th term. So we'll take away 8 from -5. So -5 take away 8 is what, -13, is it? And so it would be 8n minus 13. Hopefully. Right, let's move on. Let's do a grade 4. Okay. Oh, we've already done a speed one. So I'm going to go back to grade 3 and then I'm going to go back to grade 4. Oh my goodness. What is going on with this? What a lovely question. Thank you, OCR. 4 identical trapeziums are placed on a coordinate grid as shown. Write down the algebraic expression. Hang on, let me just set up. There we go. Write down algebraic expressions for the coordinate of point P. Okay. So it's going to be A, isn't it? Because we're given that this is A0, right? So it's going to be A. That's the easy bit, right? Now, this point here is B. So we know that B is this height here, and we know that the width of a trapezium is A. So the height is equal, so this bit here is B. Oh my goodness. So this is B here, this height here, and this bit here is B. This is trippy. This is quite an amazing question, right? So the full height here, I'll just show you on it. The full height here we know is A. And so the bit to P is the total A minus B. Oh my goodness, what a great question. So it's A minus B. Oh, the coordinates of point Q are 16, 13. I'm betting it's going to ask us to work out what A and B are, right? Work out the values of A and B, okay. Wow, alright. So let's work out all of the horizontal distances. So this is B here, right? What's this top bit? So this top bit is A minus B, isn't it? No, I don't know how to work out this section here. That's bothering me. Because we know all the rest of them. Let's see if we can work that out eventually. So that's A, distance here, and then that's A there. So is there a part of this that we can work out? Well, that's just going to be A minus B again, isn't it? Yeah, it is. It's going to be A minus B. This is a horrible question. I love it so much. So we've got adding up the horizontal ones. So we're looking at the x, okay? So a minus b plus a minus b plus b, right? I'm going to do it up here just so we've got the diagram on the screen, right? So it's a minus b plus b plus a minus b plus b, and we know it's 16, right? Because the x value is 16. So the minus b's, let's cancel them out. So b and minus b, b and minus b. So we've got 2a equals 16. So a is half of that, right? Which is 8, I believe. Okay, so let's do the other way now. So looking vertically, we've got, basically we can cheat a little bit, because we can do this a here and we can do this a minus b here, right? So we've got a plus a minus b equals 13, and so we've got 2a, or 2 times 8, which is 16, because we know what a is, minus b equals 13. Add b both sides, make it positive, take away 13 both sides, and you got what, b equals 3. Oh my goodness, what a great question. I'm sort of hoping that comes up. I'm doing recip for Eduqas. What should barely any revision I've done stressed out for big markers? Yeah, I mean, big markers are annoying, like this one, but I think when you come to this type of question, you think to yourself, okay, right, this is worth 6 marks. Was that worth the amount of time I put in it? No. Go off and get the easy marks. Go off and get some nice marks to get. But when you're left at the end of the exam, don't close your booklet. Come back to this question and go, right, let's try and work our way through it, and we can get somewhere. Maybe we can get some sneaky marks here and there. Right, let's get to grade 5. Okay, so we've got some quadratics and inequalities. And this is the last question of the paper, so we'd expect this to be quite hard. And we've got 2 squares, and we'll work out the difference of it. The trick with the difference of 2 squares is you have one bracket with the positive version and one bracket with the negative version. And you just square root both the terms. So it would be x, because the square root of x squared is just x, plus the square root of 100, which is 10, and x minus the square root of 110. Okay? So, I mean, you could rattle off 1,000 of these now, right? This will be the worst you get in a foundation paper, right? So it'll be x plus the square root of 144, which is 12, x minus the square root of 144, which is minus 12, right? And we can do x squared minus 4, and it's just memory, right? Plus 2, x minus 2. You won't get any harder ones. If you're doing higher, then they start mucking about with coefficients of x squared and all that stuff. If you're doing foundation, that's the worst it gets. We're going to solve this inequality, and the first thing we do whenever we solve anything is put our lines down. And so we've got to put our lines down. We normally put it on the equal sign, but it's an inequality. There's no equals. Now we've got x on both sides, and the rule is if you've got x on both sides, always get rid of the smaller amount of x, right? So we're going to get rid of this plus 2x by subtracting 2x both sides. Simple. So 7x take away 2x is 5x, and it completely gets rid of that 2x, and we're just left with 1. Then we're going to take away the 6. So we've got 5x is greater than minus 5. And then we're going to divide by 5 both sides. And we've got x is greater than minus 1. Just be careful, if you ever times or divide by a negative, you have to flip the sign with inequalities. Yeah, no, I agree it wasn't worth the 2 marks. Yeah, it was quite a lot of work. Can you try to attempt on more challenging questions after you finish the next question for higher paper? Right, so we keep going. I'm going to keep going. We're going to go all the way to grade 9. So from now on, for just this section, we're going to go all the way to grade 9, and then we'll loop back to grade 1. So if you want to make a cup of tea, typical British cup of tea or something, if you're doing the foundation paper, and we'll carry on going. So grade 6. Okay, so this could be on the foundation paper actually, to be fair. So maybe hold off making that cup of tea for a second, because this is from a higher paper. This is from AQA paper 1 2024 November paper higher. And what we're going to do is we're going to just focus on this top bit. So it says a plus 1 equals 5. And we're going to take away 1 both sides. I'm not going to do my lines because I'm not going to insult you. Easy. And then we just add the bottom bits, right? So 2 plus 3b equals 20. Bung our lines in. And we're going to take away 2 both sides. 3b equals 18. And then divide by 3. And b equals 6. Simples. Right, let's move on. Grade 7. Oh my goodness, we've already done quite a lot of yeah, this should be alright. Okay, so we've got this c is 2 to the power of 10 times 3 times 5 to the power of 6. Work out 18c, 18 lots of c. Okay. So 18c is just 18 times that monstrosity. Okay. But 18 we can do as product of primes. So 18 is what? 2 times 9, 3, right? So we're going to put an extra 2 in that. So instead of 10 2's multiplied together, it's going to be 11. And we're going to put an extra 2 3's in it. So it'd be 3 to the power of 3 times 5 to the power of 6. Wow, that's a horrible question. Okay. So our answer is 2 to the power of 11 times 3 to the power of 3 times 5 to the power of 6. Work out this monstrosity. So we're cube rooting everything. And actually the top bit is, that's quite interesting. I'm trying to think about how you would start this one. I think you would look at doing, whenever you cube root or square or anything, the whole of a fraction, you're basically doing it to the top and bottom. But because this is divide by 2, I think you can just get rid of that, right? Yeah. So it would be the cube root of 2 to the power of 6 times 11 to the power of 3, right? Now cube root is the same as the power of a third. Whether that's relevant, maybe it is. But actually, yeah, so if we put this in brackets, 2 to the power of 6 times 11 to the power of 3, and put a third on the outside, which is exactly the same thing as a cube root, then the rule is that you times each of the indices together. So we're going to do 2 to the power of 6, but we're going to do 6 times the third. So a third of 6 is 2. And then we're going to do 3 times a third, which is just 1. So our answer will be 2 squared. Oh, it gives it as an integer. Okay, so 2 squared is 4 times 11, which is 44. Oh, my goodness. Yeah, I think if you're doing foundation, you've just looked at that question, you're probably having a heart attack. Don't worry, this is grade 7, it's higher only. And I can barely do it. Right, circle theorems, save the day. Always love a good circle theorem. Show that y is 35 degrees. Okay, let's see what circle theorems we have. Well, we've got a cyclic quadrilateral, which is a quadrilateral that is touching every single side of the circle, and opposite sides in a cyclic quadrilateral add up to 180. So we can work out what this one is. Forgot to put my pen back. So we can work out this one is 180 take away 112. So I'm going to do, what's that going to be? That's going to be 68 degrees. So the full one is going to be 68 degrees, and you'd write this down as DCB equals 180 take away. In fact, we could just copy that and move that down. This is the beauty of computers, is you can just cheat a little bit. Don't have to rewrite anything. And you need to give reasons, right? So cyclic, quadrilateral, please write the whole thing. Then we can work out what this bit here is. So OCB equals 68 minus the 33. And I'm going to do this on a calculator only because I don't want to make a stupid mistake. I do know how to do these in my head. But right, and in fact we don't need to give a reason for that because that's obvious, because you can see that. Now, the thing that might not be obvious is that we've got a isosceles triangle here, right? Because they're both radii. And the bottom two angles in an isosceles triangle are equal. So y is equal to OCB, which equals 35 degrees. And the reason is ISOS, blah blah blah, isosceles triangle. And let me just set up, hang on. There we go. Okay, so our answer is y equals 35. Sweet. But I think there's a part B. Work out angle Z. Give reasons for your answers. Okay. Where are we going to get to Z from? Ooh. I'm trying to think. So we've got 35 here. That's where we're up to so far. And we can work out this one here. And its angle at the centre is twice the angle at the circumference. Right. So we can work out this one. If this is 35 and this is 35, then that's going to be 70. So BOC, I'm going to do it up here actually, so that you can see it. So BOC equals 180, take away 70, which will be 110. Angles in triangle add up to 180. And then Z equals 110 divided by 2, which equals 55, hopefully, if I've done it right. Angle at centre is twice angle at circumference. Wow. This is what my handwriting looks like at 7:15. There you go. All right. Cool. Let's do grade 9. Hopefully. Oh my goodness. Circle equations. Yay. That's always fun. Who doesn't like circle equations? Yeah. Right. So, find an equation of the tangent to C at point P1 where P is greater than 0. Give your answer in the form y plus square root of a x equals b. Right, let me just try and sort something out. So it's gone a bit weird. Okay. And just bear with me a sec. Okie dokie. Right. So, first thing to realise is that a circle equation is exactly that. It's a circle. And we can see this bit here is actually r squared. So the width of it is going to be 2. So it's going to be 2 in every direction, okay? So this bit here, for instance, is going to be 2, 0 as the equation. Find the equation of the tangent to C at the point P1. So C is a circle, and we're looking at the point P1 where P is greater than 0. So it's going to be 1 high, so it's going to be somewhere here. Okay, so it's going to be 1 high, and this is going to be P, so that's what we're looking for. And its P is greater than 0, so it's not this one over here, for instance. Cool, so we know exactly where it is. Right. Okay, so we're going to put 1, so the y coordinate is 1, so it's x squared plus 1 squared equals 4. X squared equals 4 take away 1 squared, which will be 3. So x is square root of 3, right? This feels really easy. What am I missing here? Okay, because we need to find what b is, right? So x is going to... yes, the x coordinate is going to be... that can't be the final bit. Okay, so we need to find the... okay, because it's a tangent. Oh, okay, confusing myself, right? So we're looking for the tangent, right? Okay, so the gradient... so whenever we're looking for a tangent, it has to have the same gradient, right? And we can look at the gradient of the radius, because we know that this point is, if we muck up, is P1. Okay, so it's the change in y, which is, so the gradient is the change in y, which is 1 over the change in x. So the gradient is 1 over p for this bit, and the gradient of the perpendicular will be, you find the reciprocal of it and then you change the sign, so it's positive, so it will turn negative, so because it's this formula here, right? m1 times m2 equals minus 1, right? So gradient of tangent is going to be the reciprocal of 1 over p, which is p, and the negative version of that, so it's going to be minus p. Oh my goodness, this is horrible. Okay. And we know that p, I mean, the x value, which we're calling p, is root 3. And so the gradient is going to be minus root 3, right? But so we've got this part here is root 3, 1, because we know what p is. Oh my goodness, this is horrible. So we've got the line is going to be y equals mx plus c, but the m we know is the minus root 3 x plus c, and that's going to be so we're going to add that to both sides, but we need to find c. How would we find c? Oh, c's, it's given to us, isn't it? C's 4, isn't it? Yeah, okay. Wow. So c will equal 4. So it'd be y plus root 3 x equals 4, which is the form we're given it in. Oh my goodness, wow. That took me way too long. I apologise for that. Sometimes grade 9 stuff do that. Right, we are back to grade 1. Wowie. And I'm doing this all live, so there is no pre-recorded stuff at all. And we are back to foundation. We're back to safe zone. Okay. We've already done this question before. So if I skip to question 2. Okay. Complete the statement. 2 meters is, well, 1 meter is 100 centimeters, so 2 meters will be 200 centimeters. 8 kilograms. A kilogram is 1,000 grams, so it'd be 8,000. This is nicer. I like this much better. Use 8 kilometers is 5 miles to convert this. So 8 times 3 is 24. So we're going to times this by 3 and we get 15, right? So it'd be 15 miles. Sweet. Let's move on to grade 2. What we got? Work out that. Okay. So with the fractions, we can find any number, and any number at the top, any number at the bottom, we can divide it by the same amount. So 6 and 12, we can divide them both by 6, so we've got 1 and 2. Then we times the tops. 1 times 5 is 5, 7 times 2 is 14. And it saves us having to simplify at the end. Sweet. Grade 3. Here is a rectangle. Yes, it is. Okay. I think this is part C of a question. So let's move on to question 22. Now, ratios are always going to be coming up on the paper. So if you don't like ratios, or you don't want to do ratios, get over it, because you will have to do ratios on pretty much all the papers probably. So it says x to y is 7 to 4, and x plus y, oh my goodness, is 88. Work out the value of x minus y. God, this is horrible. So x to y is 7 to 4. Oh my goodness me. Okay. Trying to figure out how you would start this. So you've got 88, and we know that there are okay, so this is just amounts. Okay, so there are, how many parts are there altogether? So 7 plus 4, there are 11 parts altogether. We know when you add up the x and the y, you get 88, right? So we're going to do 88, and we're going to divide by the amount of parts. So each part we know is worth 8. Okay, so that's the value of one part. Okay. So let's work out the value of x and y. So x has 7 parts, so 7 times 8 is 56. And y has 4 parts, 4 times 8 is 32, right? And then we're going to work out x minus y. So we've got to work out x, we've got to work out y, which we've done, and then we just got to subtract them. So 56 take away 32 is 24. Oh, that's a horrible question. What was that? AQA. Oh, wow. I like it though. Let's move on. Grade 4. So still on foundation, and we've got nth terms. Lovely. Work out the difference between consecutive terms. Hang on, let me just set up behind the scenes. Where am I? There we are. Okay, so the number before the n. So say if you've got a sequence of 5n plus 3, right? The number before the n is what the term is going up in. It is the 5 times table, but everything's added 3 to it, right? So the number before the n here is 2. So the difference between consecutive terms will just be 2, because it's 2n, so it's going up in 2. I'm just going to delete that in case it gets in the way later. Okay, solve 2n plus 9 is less than 99. So we're going to put our lines in. And let's get started. So we are taking away 9 first of all from both sides. So we've got 2n less than, and then that would be 90. And then we're going to divide by 2 both sides. So n is less than 45. Cool. Write down the number of terms of this sequence that are less than 99. Okay. Write down the number of terms that are less than 99. Oh, okay. So we know. So because we've solved this, we know that the number has to be less than 45. This is a really weird question. So the term number can't be more than 45, and so the number of terms will be 44 that are less than 99. That's a really cool question. I like that. That's Eduqas. Good, well done, Eduqas. Let's go on to grade 5. Okay, and yep, cool. Which 2 statements are correct? And who is this? This is AQA. Okay. Bring it on, AQA, eh? Right. So V is directly proportional to H. So directly means like this. So it's when 2 terms are on the same level, right? These aren't on the same level because the H is at the bottom and the V is at the top, right? V is inversely proportional to H. That is correct. That's inverse proportion when you've got the one of the variables as a denominator of a fraction. V is directly proportional to 1 over H. That is also correct. It's directly proportional. So if you can rewrite it as this, K times 1 over H. So it's sort of similar to the top one. It's directly proportional to 1 over H. And it's not inversely proportional to 1 over H because that's the same as that, right? That's a horrible question. Wow, it's grade 5. Right, I'm going to ask for a vote. Okay, I don't know. Can I do a vote? I'll probably do a vote. Let's do a vote. It says, engage with your audience. Okay. Have I engaged? I'll start a poll. Okay. So I'm going to ask just foundation, question mark. Just foundation. Should I pad that out? Just foundation questions, right? So we do that? Okay. You can tell I'm so experienced with doing these polls, right? I'm sort of hoping that there is... yeah. Okay, I'm going to just do foundation for now. Actually, there's another question. Would you say foundation maths is more understanding the question than knowing the hard methods? Like most people could pass if they read the questions properly. Like, it feels like that. Yes and no. Like, you still need to... So you can get grade 3 by not really understanding much maths, just remembering things. I would say to get grade 4 or higher, you kind of need to know what's going on and why methods work. Because some teachers just teach you tricks the whole time, and that's not helpful for any grade higher than sort of a grade 3. So yeah. Right, I'm going to reset back to... So I do one question, because I see the poll is 50-50 so far. I'm guessing that's 2 votes. Could be 4, who knows. So I'm going to... Maybe I'll do one higher question, and I'll make it a good one. Hopefully one I know. We've done circle theorems already. So let's see if there's... Oh, here we are. This is a nice one. So this is higher only. It's grade 7. This is just for the people doing higher. But I'm only going to do this one question, and we'll get back to foundation, right? So whenever you've got to the power of a half, it's a square root. So square root of 36 is 6. Simple. anything to the power of 0 is 1. That's on foundation as well, right? Anything to the power of 0 is 1. People write 0, they get it wrong. It's the easiest mark you can ever get, right? Anything to the power of 0 is 1. Just try and remember that. Here we've got 27. I'm going to write it bigger because you can't really see it here. 27 to the power of 2/3, right? There's a few things going on here. That means find the reciprocal. That means find the cube root. And that means then square it, right? Find the reciprocal, 1 over, simple. Okay. Find the cube root. Cube root of 27 is what? 3. 3 times 3 times 3 is 27. And then square it, which is 9. So the answer is 1 over 9. There we are. You got your higher question. Okay, so just foundations winning at the moment. So I'm going to do a few higher questions, but I'm going to whiz through the grade 1 and 3 questions. There we are. So we'll go refresh, and we'll go back to grade 1. Frequency trees. Oh, who doesn't like frequency trees? So they're at cinema, blah, 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 screen 1, screen 2, 3 times as many. Let's just highlight that. 3 times as many customers in screen 2 as screen 1. 68 paid child price. Okay, so 68 paid child price. So we're going to take away the 15, right? Because there's 15 here, and so the other 68, or the rest of the 68, must be in the other one. So is it 53? I'm assuming. Let me just set up a second, because I'm a bit all over the place in the behind the scenes. All good, right? Okay, and twice as many customers in screen 2. So it's going to be 3 times. There we go. Okay, I was going to say. So we're going to do 87 times 3, which is what, 21, 24, 25, 26. So 261. Then we're going to do 261 take away 53, which is what, 208. 87 take away 15, 72. And we can add 87 plus 261. I've shown you how to do column. I'm just going to do this in my head and hopefully get it right. Looks about right. If it's not, then I'm sure you'll let me know. Oh, that's it. Sweet. Frequency trees. Cool. Grade 2. Oh my god. Am I going to sit here and do this? Oh, go on. Why not? Castle. 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 What did you do last night? I watched someone on YouTube crossing out castle and making tallies. Watch me miscount, yeah? I've probably missed one. I don't think I have. So that'd be 11. Farm. 2, 3, 4, 5, 6, 7. Museum. 1, 2, 3, 4, 5, 6. Sweet. Right, which one's the mode? Write down the place that's the mode. Mode is most frequent, so it'd be castle. Sweet. Easy. Easy, easy. Okay, so grade 3. We've done inequalities, so I'm going to skip that. Okay. Direct and inverse proportion. Sweet. That's a good one. Direct proportion is a straight line. So it could be B, could be E, or could be C. Second thing you need to know about direct proportion is it goes through the origin. So it has to go through the origin. Of these, C is the only one that goes through the origin. So Y is directly proportional to X will be graph C. Inversely proportional is just anything that looks like that is inversely proportional, because as one doubles, the other halves. Okay, so if you imagine this point is, I don't know, 2, 1, right? As this one doubles, as the X doubles to 2, the y halves to 1. Okay, so it's going to be obviously graph D. Sweet. Right, let's move on to grade 4. Okay. Oh my goodness, I've got percentages. Okay, let me just make sure I'm ready behind the scenes. Okay. So 70% of a number is 350. Okay, so if I'm not even going to read the question. I'm just going to be like, okay, let's get started. So we can find out 10% by dividing it by 7, right? 35 divided by 7 is 5, so that would be 50. Find out 120%. So let's do, well, 100% would be 500. And 20% is double 10, right? So that would be 100. So 120% will be those two added together, which will be 600. Sweet. How easy is that? Simple, isn't it? And so many of my students at school, foundation students, would look at that and go, no, I can't do it. But actually it's pretty straightforward. Once you've practiced and you understand percentages a little bit, you can get there. Okay, and you can at least pick up a mark there. You probably only need to work out the 10% bit for a mark. So, yeah, go for it. Right, grade 5. Okie dokie. Okay. So this is the last question on the paper, on the foundation paper. So this is definitely foundation. And we're told we're given the graph of y equals x squared minus 2x minus 3. And we're asked to work out the coordinates of the turning point. The turning point is just the point the graph turns. Okay, it's that simple. Stops going down and starts going up. So that would be what, minus, no, it won't be minus. Obviously it's going to be 1 and minus 4. And find the roots. The roots are basically where it crosses the x-axis. So they will be at minus 1 and 3 symbols. Right, as promised, I'm going to do one higher. I don't know what where's the poll at? Oh wow, 80% is just foundation. So we've got one higher person, so we're going to do one higher question. Oh my goodness, what's going on with this question? I think someone's trying out their motorbike outside. I think this is quite a boring question. Essentially, the average is the median, and the interquartile range is the consistency. Okay, I'm gonna re-roll. That's a boring question. Okay, this one's a good one because this is probably a quadratic, I'd imagine. Although this is part C. Okay, let's just do this one. I don't know whether you'd need to know the other ones, but anyway. So we're going to start off by working out the differences. So that would be plus 12. That would be plus 20. I'm hoping. And that will be plus, what is that, 28? I think. Hopefully. Yeah. And then we work out the difference of the differences, right? So the difference of the differences is 8. Then you get that 8 and you halve it, and we get 4n squared. Okay, so that's the coefficient of the n squared. Now 4n squared would give us, so n squared first of all, will give us the sequence 1, 4, 9, 16, 25, right? So 4n squared would be 4 times that, so it would be 4, 16, 9 times 4, 36, is it? Hopefully. And then 16 times 4 is 64. And then 25 times 4 is 100. Now, what do you notice about the list here and the list here? Well, all the 4n squared ones are 1 higher than that, right? So we don't actually need to go any further than that because it's going to be 4n squared, and then we're just going to take away 1. There we are. 2 marks. Pathetic. It should be getting way more marks. Right, we're going to start again, and we're going to reset all the way back to grade 1. Oh, lovely. Got some negatives here. So let's get going. Minus and a minus is a plus. 4 times 3 is 12. So our answer will be 12. And I'm just going to set up behind the scenes 1 sec. Okay, positive and a minus is a minus. 6 times 5 is 30. Now we've got minus 8 squared, so that's the same as minus 8 times minus 8. 2 negatives make a plus. 8 times 8 is 64. And is there another part of this question? Yes, there is. 10 cubed. 10 cubed is 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000. Grade 1 done. Let's move on to grade 2. Oh my goodness, lovely composite bar chart. That's when you stack them above each other. Write down the number of men living in the village in the year 2000. So men are the bottom ones. So we're looking for this height here. And looking at this, this one's 50, so that would be 60. And so our answer will be 60. Oh, it's got a little place to put it. Find the number of children living in the village in 2010. So children is the bit at the top. Now this is where we've got to be a bit careful, because we need to work out what the bottom bit is. So the bottom bit will be 160 and the top bit will be 210. So that is going to be 210 take away 160 will be 50. For the people living in the village in 2020, find the ratio of the number of children to the total number of men and women. Okay, so we've got, what is it, 50, 60, 70, 80 children and 200 men and women, right? Because that's 200 total, yeah? So the ratio would be, I'm going to answer it up here just so we can see it. 80 to 200. Then we can cancel down, so it'd be 8 to 20, 4 to 10, 2 to 5. So you can cancel it down. It doesn't actually say you have to, so we could leave it as 80 to 200 and still get the marks. Sweet. Grade 3. Oh, gosh. Lots of words. But I do like the fact they're called A, B and C, and I'm just going to call them A, B and C. They're given cash tips when working in a cafe. They share the tips in the ratio of the hours they work each week. 1 week, Ahmed works 5 hours. So I'm going to do A to B to C. So A works 5 hours, B works 6 hours, and C works 12 hours. Kath's share of the tips for this week is 18. Okay, £18. Work out Ahmed's share of the tips. Ooh, this is quite an interesting one because the numbers don't really work that nicely. In a way. So 5. So I would do. So we could go to 6, and we can ignore B because B's not really anything to do with this. So we halve it to go to 6, so it'd be 2.5. Okay, so what I'm doing is I'm halving it to go to 6. And the reason being is I know then I can times it by 3 to go to 18, right? 2.5 times 3 is going to be 7.5, or £7.50. Sweet. The following week, the tips total is 72. B works twice as many hours as A. C works 3 times as many hours as A. Okay. So we're going to do A to B to C. Now we've got to put one of them as 1 because A is being compared to each time. I'm going to put A as 1. And it says B works twice as many, so it'll be a 2, and C works 3 times as many. Okay, next we're going to add up and see how many parts there are altogether. So that'll be 6 parts altogether. And there are £72 in total. So we're going to do the £72 divided by the 6, which will be 12. So each part is worth £12, and we're looking for Blake's share. Blake has 2 parts, and we times that by the £12, which will give us £24. Ratios can be a bit all over the place, but I think the more you practice with them, the better you'll get. Right, grade 4. I think I've answered, I answered this question before. Hardly anyone was here when I answered it because it was one of the first ones I did. So I might do it again because it's quite a nice question. So it's quite complicated as well. So the ratio, the radius of the big circle and the radius of the small circle. The radius of the large circle is 12. And it says the radius of the large circle is a ratio of 4:1 to the small circle. So we are first of all going to divide the 12 by 4 to get 3, right? Because if I times this by 3, I get 12, and I can times this by 3, and I get 3. So it'd be 12 centimeters and 3 centimeters. The area of a circle is pi r squared, and the to work out the shaded area, we're going to do big take away small. The big circle take away the small one, right? So the big one is going to be pi times 12 squared. And we're going to take away, I'm going to put them in brackets, make it a bit simpler. Take away pi times 3 squared. 12 squared is 144. And you can write this as 144 pi, right? And 3 squared is 9, so we can write that as 9 pi. Now, you can sort of treat this as like in algebra, right? Where you'd write x. Pi sort of works the same way, that you can add and subtract them. So 144 pi take away 9 pi is 135 lots of pi. And it says give your answer in terms of pi. That's our answer, 135 pi. Right, grade 5. Oh my goodness, what is this? So Nia and David are working out area of a sector of a circle. They must give the answer as a multiple of pi. Nia's answer is that. David looks at Nia's answer and says your answer's wrong. Explain the error that Nia's made. Calculate the correct answer. So 360 divided by 45 is 8. That is correct, and that's what you'd want to do. So we've got an eighth of a full circle, because 90 would be a quarter, 45 would be an eighth. The area of the full circle is pi times 24. Oh my goodness. The circumference is pi times d. The area is pi r squared. So what she should have done is it's step 2. She used the wrong formula. Should be pi times 12 squared, right? Unless, yeah, okay. So that would be 144 pi. And then we're going to times that by an eighth. To find an eighth, you halve it again, and halve it again. So 144, half that is 72, half that is 36, and half that is 18. So that would be 18 pi, hopefully. Hang on, one sec. Was it 28? Let's just check that one if I can. Don't think I can. So I'm pretty sure that's right. Right. We've got one higher person here, so we're going to do one higher question to keep them interested, assuming they're still here. Hope they are. Okay, all right. This is famously, I'm going to crash and burn. Algebra is not something that's nice to stream, because if you go down the wrong path, it can be quite brutal. So a cubed b over 7 plus 5 equals c, and we need to make a the subject, which means we need a equals. Go get our lines in. So there's some quite nice easy bits we can do first. we can take away the 5 both sides, right? Simples. A blah 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 equals c minus 5. Next we can times that 7, free up the fraction, get rid of the fraction, and that would be 7c minus 35, because you've got times everything by 7. And then we can divide the b both sides. So it'll be a cubed equals 7c minus 35 over b. My b's and 6's look identical. I try my best. Finally, we can cube root both sides. This wasn't so bad. I don't mind this one. So a equals the cube root of 7c minus 35 over b. And we could have the top in brackets, but there we go. Nice, easy, higher one. Right. As requested, we're going to loop back to grade 1. Okay. And let's do question 1. So we've got to tick whether they are prime, odd, even, square, etc. So 1 is not prime, 2 is prime, 8 is not, 9 is not. 2 is not odd, 9 is odd. Even is these two. Square is 9 because it's 3 times 3. Cube is 8 because it's 2 times 2 times 2. Sweet. There we go. Grade 2. One sec. Okay, so plot the point 3, 2. So 3, 2 would be here. So along the corridor up the stairs, write down the coordinates of the midpoint BC. So the midpoint would be the bit in the middle, which is here, and so that would be minus 1, 0. Sweet. On to grade 3. I've already done quite a few speed ones, so I'm going to re-roll. Do another grade 3. I've done best value ones. Alright. Yeah, I'm trying to find one that I haven't done yet. I'm going to re-roll. Okay. On the grid, draw a shape congruent to triangle A. Congruent means exactly the same. So it's going to go 3 down and 3 across and 1 up, and then done. Sweet. On the grid, enlarge shape B by a scale factor of 1/3. So scale factor of 1/3 means that we're going to divide it by 3. So 1, 2, 3, 4, 5, 6 high, 3, 3. When it's scale factor 1/3, it will be 2 by 1 by 1, and then just join it up. Sweet. Grade 4. I did those ones earlier. Try to find ones that we haven't done yet. I'm going to re-roll. Okie dokie. We did one very similar to that earlier. Is this just all front elevations now? Right, on the grid, draw the graph y equals 1 minus 4x. And I'm just going to write that down here so that we've got it when I scroll down. So the 1 means it will cross the axis at 1. And the minus 4 before the x means its gradient will be, for every 1 it goes across, it will go down 4. So we're going to go across 1 and down 4. So 1, 2, 3, 4. And across 1 and down 4. 1, 2, 3, 4. Now you might be wondering why I've gone across 2. It's because on this axis, on this scale, 2 is 1, right? And I've got to be careful here. It will be going down. Oh no, go all the way down. Okay, so let's keep going a little bit so I can draw it. I'd normally put the ruler down. 1, 2, 3, 4, but I don't have a ruler. 1, 2, 3, 4. I've got to sort of do it with the tools I have. Let's join them up. It's annoying. I can't get it perfectly on the screen, so it's missed a bit here. But make sure yours doesn't. Should probably go right to the edge. Not got that perfectly. We can move it a little bit. Jiggery pokery. Sweet. There we go. Done. Right, grade 5. Have we done this? Darcy says the statement in the box is an equation. Ellis says the statement in the box is an identity. Which one of them is correct? So Ellis is correct. An identity means that it works for any value of x. It's really that simple. So you could put any value of x in there, and it would work. Sorry, one sec. So because it would work for multiple values of x. So when you've got an equation like 2x equals 10, right? There's only a finite amount of x values that will work for that. Well, just one. Okay, only 5 work. But when you've got like x plus x equals 2x, like you could put anything as value of x there and it would work. Right, solve by factorizing. Going to put our brackets down. And we're going to always have x in for foundation paper. And we need two numbers that times together to make -12 and add together to make 4. And so we need them to have a difference of 4. So 6 and 2. They make a negative when they multiply, so they have to be different signs. So it'd be 6 and 2. 6 plus -2 is 4. 6 times -2 is -12. Now get each of these brackets equal to 0 to solve. So x plus 6 equals 0. Get our lines down. -6 both sides. X equals -6. Do the same with the other one. +2 both sides. X equals 2. And you'll notice they're just the opposite signs than are in the brackets, right? So x is -6 and x is 2. Right, I'm going to do my last question. So I am severely losing my voice. Someone wanted to do grade 9, so let's go straight to grade 9. Why not? As long as it's a good one. No, I'm not doing a proof of triangle. Let's re-roll. Let's re-roll. Let's get a nice one. Okay, prove algebraically that the sum of any two consecutive terms in the sequence is always a multiple of 4. Oh my goodness. So sum means add, consecutive means next to, and multiple of 4 means that we're going to end up with something like 4n, right? So we can first of all put a value in, and we could put 1 or 2 in, but I'm going to put x in. So 2x squared plus 1. And the consecutive one, so the next one along, would be 2x plus 1 squared plus 1. Okay. Now the reason I'm adding them is because it says that the sum of two consecutive terms. So we're adding the two together. Okay, if that makes sense. Maybe it does, maybe it doesn't. We're adding the two together, and they need to add together to, and magically they will make a multiple of 4. Okay, so first thing I'm going to do is expand the brackets I've made there. So 2x squared. We don't need the brackets around these. I've just sort of had those there to show you them. And I'm going to expand this, so we've got x squared plus 2x plus 1 plus 1. Let's get rid of the other brackets that we've still got. So we've got 2x squared plus 4x plus 2 plus 1. 2x squared plus 2x squared is 4x squared. 1 plus 2 plus 1 is 4. And we've got that 4x there. Now notice we've got 3 terms all with a 4 in the front of them. So we've got 4 brackets x squared plus x plus 1. And because we are timesing it by 4, then it must be a multiple of 4. So you'd say like something like it must be, because it is the bracket is times by 4, it must be a multiple of 4. Right, I'm going to save it there. I'm just going to check the comments. What have we got? 2024 paper was a bit tricky. Depends what, I don't really know what year you're talking about. This one is higher. It's grade 9, the one I've just done. Cool. I'm going to see whether I can do this tomorrow. So if you want to join me, the exam is on Thursday, and today is Tuesday, so tomorrow will be the day before the exam. So I will try my best to make it here. Otherwise, you can check out onmaths.com. We've got loads and loads of stuff there. I'm doing higher and foundation, but I did a poll earlier to see what people wanted me to cover, and I'll probably do the same again tomorrow. And if more people are wanting to do foundation, then I will do some foundation ones. If there's people who want to do higher, I'll do some higher ones. But I'm going to quit now because my voice is about to disappear completely. So thank you very much, and hopefully I'll see you tomorrow. If not, good luck with your exams.